every point on the unit circle can be defined in the form of cos and sine. Sin x becomes 0 for n pi values. So therefore here x is not equal to n pi. So this is the condition of cosecant x under unit circle. In the second quadrant, only sine and cosecant are positive because value of b is positive, value of a is negative. Since a is negative, all other remaining functions are negative. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about trigonometric functions under unit circle. So let's see the definition of all 6 trigonometric ratios in terms of unit circle. Now here, consider a unit circle here and consider any point P on the unit circle. So here, when I say consider an unit circle, we know the radius is 1 unit. So therefore, on your xy plane, let me take the center of the circle as origin itself. So therefore, the distance of a point A, B, C, D, that is point A, point B, point C, point D from origin will be 1, and hence their coordinate are 1, 0, 0, 1, minus 1, 0 and 0, minus 1. So consider any point P on the unit circle. Then from the point B, draw a perpendicular PM to the x-axis. So you will get a right angle, that is POM. Now angle AOP is x radians. So angle AOP is equal to x radians now, because I am defining the trigonometric function in terms of radians inside the unit circle, and distance of point P along x-axis is A and distance of point P along y-axis is B. That's why we represent it in the form of P of A, B. Now, we know that in any right angle triangle, if x is the angle, then we call this as an opposite side, adjacent side and hypotenuse. So, what is the definition of cos x? Cos x is always adjacent side by hypotenuse. Consider the triangle here, that is OPM. So for angle x, we have adjacent side as A, opposite side as B and hypotenuse as 1. So therefore, according to the triangle here, we have cos x is equal to A by 1, which is nothing but A. Similarly, we will take sin x. Sin x is the ratio of opposite side by hypotenuse. So therefore, it is B by 1. So we can write it as B by 1. So therefore, it is equal to B. Hence, the point A, B can also be written in the form of cos x, sin x for any angle x. So therefore, you can clearly see we have got cos x is equal to A, sin x is equal to B, which is the x coordinate as well as y coordinate. Hence, any point on the circle can also be represented using trigonometric ratios of cos and sine irrespective of their angles. If it is angle y, then we can represent it in the form of cos y, sin y. Suppose if here is any point Q here with an angle y here, the total angle is y, then we can write point Q as cos y, sin y. So this is how we can represent any angle on the unit circle with coordinates as cos and sine. Next, in triangle OMP here, we can observe that OP square is equal to OM square plus PM square. That is the Pythagoras theorem. What is OP? OP is 1. So 1 square is 1 now. What is OM? OM is A. So we will get A square, and here we will get PM as B. So B square. But what is A here? A is cos square x and B is sine. So therefore this can be written as sine square x. So this is one of the important trigonometric identity which we have learnt earlier in terms of a triangle, right angle triangle. Here we are describing the same relation in the unit circle. Hence, we define the relation cos square x plus sin square x is equal to 1 as an identity. So, we define cos square x plus sin square x is equal to 1. Next, we know that one complete revolution is nothing but 2 pi. So therefore here angle AOB is pi by 2, that is 90 degree. So clearly you can see here angle AOB is pi by 2. Angle AOC is pi. That is half of semicircle, no? So therefore it is pi. It's a straight angle. Next, angle AOD is 3 pi by 2. That is 270 degree. And that is angle AOA means 1 complete revolution. That will give you 2 pi radians. So now you can observe the coordinates here. So according to the angle defined here, you can also observe the coordinate. So at the point A, the coordinates are 1, 0. So that means if there is no inclination for this ray, the angle is 0. So how can that angle 0 can be represented at the point A here? So clearly we know that every point on the unit circle can be defined in the form of cos and sine. So therefore here we are getting cos of 0 as 1, sine of 0 as 0. So from the diagram we can write sine 0 is 0 and cos 0 is 1. Now I said, so B is a point of pi by 2, that is AOB is a pi by 2. So for 90 degree, we have a coordinate 0, 1. So what does it represent? That can be represented as cos pi by 2 is 0 and sin pi by 2 is 1. Next we can see this is our straight angle 180 degree, that is pi, whose coordinates are given in the form of -1 and 0. So from the diagram again I can write cos pi as -1 and sin pi as 0. Next from here to 270 degree, so we can clearly say that cos 3 pi by 2 is 0 and sin 3 pi by 2 is -1. Similarly, 1 complete revolution, that means 360 degree, which in terms of radians it is taken as 2 pi. So therefore cos 2 pi is 1 and sin 2 pi is 0. So this is how we will identify any point on the unit circle and we can write the values in terms of coordinates. So thus any point P on the unit circle can be expressed in terms of an angle in radians as cos x, sin x. However, I have taken x as cos x, sin x. So pi by 2 can be written as cos pi by 2, sin pi by 2. This can be written as cos pi, sin pi. This can be written as cos 3 pi by 2, sin 3 by 2. Since the coordinates are already defined, the value of pi by 2, 3 pi by 2, pi and 2 pi of sine and cos are the respective values. We also observe that after 1 complete revolution here, the angle x increases or decreases. So that is, if we turn it on anti-clockwise direction, the angle increases. If we take it on a negative direction, the angle decreases. So based on the increase and decrease in value, however you go, after 1 complete revolution, the point or any point. So if you start from P, after 1 complete revolution, the point will be on the same position. But only difference is the angle is changed. So therefore, even though angle is changed, the point will lie on the same position. Hence, for many angles of trigonometric ratios, the value will repeat for certain angles. That is nothing but all trigonometric functions are periodic. That is, after 1 complete revolution, the value of the trigonometric functions will go on repeating. That is why we call it as a periodic function. So therefore, when you consider sine function here, sine is periodic after 1 complete revolution, because you can clearly see sine 0 is also 0, sine 2 pi is also 0. If you take after 360, you add plus 90 to 360, then it is clearly 450. So where does the point 450 comes? Here only. So that's why cos 450 is 0, sin 450 is 1. Only the angle changes, but the value will repeat after certain intervals. Hence, we call all trigonometric functions as periodic functions. Also, you can observe here sin 0 is 0 and sine pi is 0, sine 2 pi is 0, sine 0, 0, sine pi is 0, sine 2 pi is 0. That means after adding exactly pi radians each time, the value of sine is becoming 0. So generally we can write it as sine n pi is always 0. Sine any pi is 0. Sine pi, sine 0, sine 2 pi, sine 3 pi, sine 4 pi. For all integer value, sine function is 0 for n pi. Sine 2n pi plus x. That is after one complete revolution. If you get any angle, then you can express it as a sum of 2 pi plus some angle. Suppose if you have 420, then you can express it as 360 plus 60. Because sine 360 is 0, it is same as sine 60 degree because the point will lie on the same position wherever sine 60 was lying. So therefore, any angle when you add with multiples of 360, it is same as your sine x. As in case of sine, we can also see cos is also 0 for certain values of trigonometry. So clearly you can see here cos pi by 2 is 0, cos 3 pi by 2 is 0. So here you can clearly see for pi by 2 value, that is odd multiples of pi by 2, cos function will become 0. So therefore we can write cos odd multiples. Odd multiple means odd number 2n plus 1 pi by 2. Cos function will become 0 for all n belongs to z here. So for any odd multiples of pi by 2, cos value is always 0. And as in the case of sine also, cos 2n pi plus x is same as cos x. So because when I say after 360, when you get any angle more than 360, it can be expressed as 360 plus x form. Since the value is periodic here, the point lies on the same point. So whose value is same as x. That is why cos 2n pi plus x can also be written in the form of cos x. So now we have defined sin x and cos x in terms of unit circle. The remaining functions are cosecant x. We know that cosecant x is a function which is a reciprocal of 1 by sin x. We know that sin x becomes 0 for n pi values. So therefore here x is not equal to n pi. So this is the condition of cosecant x under unit circle because it is not defined. Sin any pi is 0. So 1 by 0 is not defined mathematically. So therefore the cosecant function can be defined for all the angle except n pi. Next we have secant x. Secant x is a reciprocal of cos x and cos x is 0 for odd multiples of pi by 2. So therefore here denominator cannot be equal to 0. Hence x cannot take the values of 2n plus 1 pi by 2. Because for the values 2n plus pi by 2, cos function becomes 0. Next we can define tan function. We know that tan is a ratio of sine function over cos function. Hence, tan cannot take the value of odd multiples of pi by 2 because for those value, the denominator where we have a cos as a denominator gets 0. Next, we have cot x. Cot x can be defined as the ratio of cos over sine, but x cannot be equal to n pi here. If x is equal to n pi, then sin x becomes 0, which will be in the form of 1 by 0 form or anything divided by 0 form, which is not defined mathematically. Hence, except for n pi, cot x can be defined for all other angles in unit circle. So, we also got a relation between cos and sine using Pythagoras theorem, that we have got cos square x plus sine square x is equal to 1, which is very important identity. So from this we can also derive other two derivatives. So if we divide this equation completely by sine, then cos square by sine square is cot square x. Sine square by sine square is 1. 1 by sine square is cosecant square x. Because we know that 1 by sine can be written as cosecant x. Hence 1 by sine square become cosecant square x. So cot square x plus 1 is equal to cosecant square x is also one of the identity. Next, if I divide this complete equation by cos square x, here you can see cos square x by cos square x is 1. Sin square by cos square becomes tan square because sin by cos is tan. 1 by cos is secant. So 1 by cos square becomes secant square x. So these are the three important identities which we can derive from the unit circle. That is cos square x plus sin square x is 1. 1 plus cot square x is cosecant square x. 1 plus tan square x is secant square x. Next we will learn the sign of trigonometric function in the different quadrants here. How we can see here PA comma B is a point whose mirror image, that is QA comma minus B, can be defined here. But what is the difference here? Now see here, suppose the angle is measured in clockwise. Clearly we can see there cos x is equal to A. And suppose the same angle, if this is the angle x and this is the angle minus x here. So I'm measuring in anti-clockwise. So we have here cos of minus x. What is cos of minus x? If I take minus x as an angle, then A is the adjacent and here 1 is the hypotenuse. So again you will get it as A by 1 only. So which is A. What is A? It is cos x only. But let me take sine of minus x. What is sine of minus x? Sine of minus x is opposite side by adjacent, which is minus b by 1, which can be written as minus b. But what is actually b? B is nothing but sin x. So therefore we will get sine of minus x as minus sin x. So thus, except for cos and secant of minus x, we will get secant x only. Except for cos and secant of negative angle, all other trigonometric function will be negative. That is, sine of minus x is minus sin x, cosecant of minus x is minus cosecant x, tan of minus x is minus tan x, and cot of minus x is minus cot x. So this is how we will define the cos of positive as well as negative angle. Since here I have taken an angle in first quadrant and second quadrant, so this is what I have got. So now if I take the point on the first quadrant, we know that A and B are positive. If A and B are positive means cos x is equal to A, sin x is equal to B. And we know that A comma B is positive. So cos x is also positive, sin x is also positive. What about the remaining angle? We know cos x positive, sin x is positive. So therefore secant x is also positive because cos x is positive. Sin x is a reciprocal of cosecant, hence cosecant is also positive. Tan, since sin by cos is tan, both are positive. So therefore tan is also positive. Cot is cos by sin. Since cos and sin are positive, cot is also positive. Hence, in the first quadrant, all trigonometric functions are positive. Suppose I take the same point on the second quadrant. Let me take this as the point. So let me take this as any angle. So like however A is defined here, we can clearly say in the second quadrant, A is negative, B is positive. That means cos is negative and sin is positive. So based on this first quadrant, so this is second quadrant, here all are positive. So based on the sign of cos and sin, the remaining angles of trigonometric ratios are positive and negative. Since cos is negative, secant is negative, tan is negative, and cot is negative because all these ratio contains cos. Whereas sin is positive, so this implies cosecant is positive. Now let me take the same point in the third quadrant. We know that in the third quadrant, both x and y coordinate are negative. So here the point will be in the form of minus a comma minus b. So that means your cos is negative, sin is negative. So here in the third quadrant, cos is negative, sin is negative. So since cos is negative, secant is negative. Since sin is negative, cosecant is negative. What about tan? Tan is the ratio of sin by cos. Negative by negative, it is positive. So therefore, in the third quadrant, tan function is positive. Similarly, cot function is also positive because it's a ratio of cos by sine, negative by negative, so it becomes positive. Now in the fourth quadrant, we have a comma minus b. We know that a is positive, that means cos is positive. Minus b if you have sine is negative. So here we have cos positive and sine negative. So this implies secant is positive, cosecant is negative. So if any one of these two functions are negative, the ratio of tan and cot is also negative. So therefore we'll get tan is also negative, cot is also negative. So depending on the point lies on the quadrant, the trigonometric function changes its positive or negative value. So thus we have here 4 different quadrants. You can clearly see here I have divided the quadrants into first, 2, 3, 4. That is first, second, third and fourth. So in the first, all are positive because both A and B, any point on the first quadrant is positive. That's why cos and sine is positive. Since cos and sine both are positive, all functions are positive. In the second quadrant, only sine and cosecant are positive because value of B is positive, value of A is negative. Since A is negative, all other remaining functions are negative. In the third quadrant, cos and sine both are negative. So therefore, the ratio containing cos and sine is tan and cot, except tan and cot, all are negative. So that's why in third quadrant, tan and cot functions are positive. Similarly, in fourth quadrant, cos and secant functions are positive. So now this is how we will describe the sign of the trigonometric functions in terms of quadrant. Now we will see the sign of trigonometric functions in different quadrant. Now function we have here sin x, cos x, tan x, cot x, secant and cosecant. In the first quadrant, all are positive. In the second quadrant, sin and cosecant are positive, all are negative. In the third quadrant, tan and cot are positive, all are negative. In the fourth quadrant, cos and secant are negative, all are negative. So here are the sum of the standard values of different angles given in terms of trigonometric function. So based on the location of a point, the angle is described and the value of the angle is recorded. So here are the few angles with respect to their trigonometric functions. So we have 0 degree, 30 degree, 45, 60, 90, 120, 135, 150, 180, 270, 360. And these are the radian measures of these angles. 0, pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, 3 pi by 4, 5 pi by 6, pi, 3 pi by 2, 2 pi. So these are few standard angles of one complete revolution. Any angle more than this can be converted into sum or difference of these angles. Now we have here sine 0 is 0. We know that in a unit circle, the first coordinate is 1, 0. So therefore cos 0 is 1, sine 0 is 0. You can see here cos 0 is 1, sine 0 is 0. And we have learned for pi by 2 also. So 5 pi by 2 we have 0, 1, which represents cos pi by 2 as 0, sin pi by 2 as 1. So based on the location of a point on the unit circle, these values are defined. So sin pi by 6, 30 degree is 1 by 2, sin 45 degree, sin 60, sin 90, sin 120, sin 135, sin 150, sin 180, sin 270. So you can also see we have negative signs for few angles because of the angle lying in the quadrants. So you can clearly see from 0 to 90 degree means all values are positive because cos is positive in the first quadrant. Now from 90 to 180 degree, you can clearly see we have negative values of cos because in the second quadrant, cos is negative. And again in the third quadrant, negative. So in the fourth quadrant, it is 360. 360 means it almost comes close to a 0 angle which lies in the first quadrant. Again in the first quadrant, cos is positive but whose value is same as cos 0 degree. So similarly, the values of tan is given, not defined. Why? Because tan is a ratio of sine by cos. So when I take tan 90 degree, it is sin 90 by cos 90, whose value is 1 by 0. Since 1 by 0 is not defined, we have written not defined here. So similarly, 180 is 0 by minus 1, which is 0. 0 divided by anything will always remains as 0, but anything divided by 0 is not defined. Next, we have the same values for cosecant function, secant function and cot function. Again, not defined indicates since sine is a reciprocal of cosecant. So, sine 0 is 0, but cosecant 0 is 1 by sine, which is 1 by 0, not defined. So, and we have here sine 30 degree as 1 by 2. Cosecant is reciprocal of sine, so it is 2. So, whatever the value you have for sine, the same value is in the case of reciprocal in terms of cosecant. Similarly, cos value is taken as reciprocal for secant, tan value in the form of reciprocal for cot function. Next, we will see the domain and range of this trigonometric functions. So, here is a graph I have written according to the given value. So, I have plotted angles along x-axis and real numbers on y-axis. So, we know that sine 0 is 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 0. Similarly, if the angle is negative, sine minus 90 is minus 1, sine minus pi is 0 because sine any pi is 0, so 2 pi also 0, sine minus 3 pi by 2 will take the values of 1. So, by observing this, I will draw a line. You can see here, this line parallel to x-axis is intersecting the graph at many points. What does it indicate? It indicates this function has same value for many different angle. See here, for sine pi by 2 it is 1, 3 pi by 2 it is 1, 2 pi 0, pi 0, 0, 0, pi 0, 2 pi. Draw any line parallel to x-axis. You have many intersection of the points along with the graph. So that means sine function is periodic function. The value of sine function will repeat for many angles. Also, you observe that the maximum value it can reach is 1 and the minimum value it can reach is minus 1. So, therefore, for any angle, the domain will be the real angles. Hence, for sine function, the domain is any real angle, whereas the range always lies from minus 1 to plus 1. We can also write in the form of an interval form, that is minus 1 comma 1. Thus, the range of sine function is minus 1 comma 1. Similarly, you can observe the cosine function, cos function. So, if you plot the values taking real angles on x-axis and real numbers along y-axis, this is the graph you will get. So, here also, if you draw any line parallel to x-axis here, it intersects at many points, which says that cos function have same values for different angle. That indicates cosine function is also periodic. But observe the graph here. Here also the maximum value it can reach is plus 1, minimum is minus 1. Hence, for any real angles, the range of cos function is also minus 1 to plus 1. Domain is x belongs to R, any real angle, range is minus 1 to plus 1. Next, tangent function. We have defined the tangent function for all angle except odd multiples of pi by 2. Why? Because tan function is a ratio of sine by cos. Since cos is in the denominator, it cannot take the value 0. Hence, 2n plus 1 pi by 2 of cos function will remain 0. Hence, for other than this angle, the domain of the tan function can be any real number other than odd multiples of pi by 2. And range is any real number because tan 90, you can see here tan 90, tan minus 90, tan minus 270, it is defined, not defined, it turns to infinite value. So, therefore, the value of the tan function goes on increasing on positive side and decreasing on the negative side of y-axis. So, therefore, it can take any real value. As in case of tan function also, cot is also defined for the domain where it is not equal to n pi. Other than n pi angles, it is defined for all angles and the domain of cot function is also any real number, because you can see the graph here, the value of the graph goes on increasing on the above the axis and decreasing below the x-axis, which indicates the infinite values of the function. Next, we have a secant function. Secant function is a reciprocal of cos, hence it is defined for all the real angle except odd multiples of pi by 2, but the range of secant function does not lies between -1 to +1. Therefore, secant function can take any real value as a range except -1 to +1. Why? Because the cos function is defined in this range. So therefore, except this values here, -1, +1, range of secant function is R. The graph of cosecant function is given here. Cosecant is a reciprocal of sine. Sine becomes 0 for n pi. Hence, other than n pi values, the domain of cosecant function is any real angle, whereas the range is any real number except for the interval -1, 1, because sine function is defined in this particular interval where n pi will become 0. Hence, except that those interval, it is defined for all other interval. So this is the graph of cosecant function for different values of different angles. Thus, here is a short table which helps you to study about the domain and range of x. So this is sine, cos, tan, cot, secant, cosecant. So domain of these function. So for sine and cos, domain is same, range is same. And for tan, domain is r minus odd multiples of pi by 2. Cot is r minus n pi, whereas the range for cot and tan is same, and range of cosecant and secant is same, but domain is different. For secant, domain is r minus odd multiples of pi by 2, and cosecant it is r minus n pi. So thus I hope you have learned how we will define the trigonometric functions or ratios under the unit circle. We will study few more concepts in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.